Assalamualaikum and a very good day. My name is Syeddre bin Sutarno. Today I will present my research studies, which is investigation on the compaction characteristic of Sabah Peat soil stabilized with eco-process Pozzolan. So let's moving forward to abstract. Peat soil is defined as the highly organic surface layer derived primarily from plant remains. It has a dark brown to black color and organic odor and a spongy consistency in general. Peat soil have a low shear strength, high compressibility and high moisture content. Peat also has a lot of deformation, lot of magnitudes and many screens, and it contains a lot of organic stuff. Eco-process Pozzolan as a peat soil stabilization material with improved technique and its consequence of the method, the peat soil index properties and analyze the under shear strength characteristic. So before we proceed to the next presentation, I will present my list of content. The first one, what we have been through just now is abstract, followed by introduction, testing and method, result in discussion, and lastly conclusion and discussion. So in the previous study, the term peat soil was defined as the highly organic surface layer derived primarily from plant remains. On the other hand, peat was defined as unconsolidated superficial deposit with high non-crystalline colloid content constituting the subsurface of wetland system. Generally, it has a dark brown to black color and organic odor and mostly has a spongy consistency. There was a time when the plant fiber were visible and sometimes they may not be in the advanced stage due to the decomposition of the peat soil as claimed by Mohd 2014. Peat soils are characterized by high water table, absence of oxygen, reducing conditions, low bulk density and bearing capacity, some spongy substratum, low fertility and usually high acidity, according to Usman 2018. Eco-process Pozzolan is a pozzolanic material have long been utilized as a substitute for cement. The incorporation of pozzolans can be reduced the cement quantity used, according to Chinda Parasit 2007. APP contains amount of SiO2, aluminium oxide, iron oxide, which makes up 68.98% of its overall chemical composition, exceeding the STM C618 requirement. Blended cement has been produced using eco-process Pozzolan, which is derived from the waste generated during the crude palm oil, degumming and bleaching processes at refinery facilities. So moving forward to problem statement. Prior to the work of Razal 2013, peat soil were known to have low shear strength around 5 kPa to 20 kPa, high compressibility 0.9 to 1.5 and high moisture content which is higher than 100%. Peat also has a large deformation, high magnitude and rate of settlement and contains organic matter which is larger than 75%. Therefore, peat soil is not suitable for placing any foundation, road or other construction in the peatland. Pursuant to the Duraisamy 2007, peat commonly occur as extremely soft with unconsolidated superficial deposits, normally as an integral part of wetland system. So the objective of this study is to determine the peat soil index properties. Second one, to determine the optimal mixture of eco-process Pozzolan EPP for peat soil stabilization. And third one, to analyze the changes in dry density of the peat soil before and after treatment. Is moving forward to the significance of study. This study is enlarged from the previous research on peat soil and at the same time provides suitable behavior of peat soil with EPP to improve soil properties and fill the gap on the undrained strength characteristic that focus on peat soil. Establish a new method in the industry that can be tried as a new product for the peat soil stabilization using eco-process Pozzolan. Is to fill the gap because no researcher have found out on the mixture of eco-process Pozzolan as a stabilizer with peat soil to improve their properties. So let's proceed to testing and method. The aim of this research is to examine the compaction properties of peat soil stabilized with eco-process Pozzolan. The laboratory work and tests applied in accordance with British Standards Research Method for soil civil engineering purposes are described in depth to establish the study's findings. The soil humic deposit was examined at Clear Peat Soil Field Center, Beaufort. The laboratory test on a peat soil sample was conducted to investigate the sample soil properties and features. So this is the flow chart that show my all the research that I've been followed. The location of Clear Peat Soil Field Center in Beaufort, Sabah were documented based on the presence of adequate peat soil deposit. The collected sample were then transported from the field to the Malaysia Universiti Sabah Geotechnical Laboratory, and proper sample storage procedures were implemented and explained. During the sampling process of peat soil from the site, a bone-post scale was used. The research included 3 types of tests: index properties, settlement behavior testing, and treated and untreated soil analysis. Standard tests were conducted to evaluate the degree of humidification, moisture content, and other index properties of the soil. Compaction tests were performed to assess the soil settling behavior using 4.5 kg drop weight and 45 cm drop height, and the soil was compacted at 5 level with 27 blow each. The technique and procedure for obtaining soil sample vary depending on the sampling objective. Soil sample may need to be analyzed to discover the soil properties and characteristics. This study defines soil sampling for research purposes which aim to enhance peat soil using compaction stabilized by EPP. So this is the sample used in this research, which is pipe sample will be used for this use, which is peat soil plus 10% of EPP, pin soil plus 20% of EPP, peat soil plus 30% of EPP, and peat soil plus 40% of EPP. The selected amount of EPP is based on previous research and fills the gap as no researcher has used the same amount of EPP in previous study, and EPP was only used as a stabilizer. So let's moving forward to result and discussion. For the index properties for this research is natural moisture content is 587.57%, specific gravity 1.47, acidity and pH 2.34, organic content 86%, fiber content 69%. So this is the graph for the untreated. So the untreated peat soil were employed for the compaction test. As a consequence, the graph was in the downward trend with 2 identical data point of 0.58 mg per meter cube, dry density in test 3 and 4, while the greatest dry density was 0.59 mg meters cube. So the R square for the test was 0.0347 and the highest moisture content was 55%. The R square is low. The error may cause it during the test because the test is not finished in a day. A few days are taken to get all the data. Let's proceed for the peat soil plus 10% of EPP. The peat soil added of 10% of PP for the compaction test. Therefore, the figure shows the graph was in upward trend with the highest dry density was 0.63 milligram meter cube, which was in test number 4. Meanwhile, the lowest dry density was in the test number 1, 0.57, and R square for the test was 0.047, and the highest moisture content was 69%. So let's moving forward to the peat soil. We added mixture of 20% EPP for the compaction test. The graph shows an upward trend with the highest dry density being 0.65, which was in test number 4. Meanwhile, there was a identical dry density was in test 1 and 2. The R square for the test was 0.9245 and the highest moisture content was 69%, while the lowest was 36%. So for the addition of 30% EPP, the figure shows the graph was in upward trend with the highest dry density being 0.7, which was in test number 4. Meanwhile, the lowest dry density was in test number 1, 0.67. The R square for the test was 0.999 and the highest moisture content was 55%, while the lowest was 32%. So the 40% EPP has been added to the peat for the compaction test. The figure shows the graph was in an upward trend with the highest density being 0.7 and which was in the test number 4, while the lowest density is in test 1, 0.66. Then R square for the test was 0.8239 and the highest moisture content was 51%, while the lowest was 31%. Let's move into the next slide, which is the comparison between the 5 samples. The figure shows the different color of the line that represent each sample. The data from this study suggests that EPP has a high potential as a stabilizer for peat soil, which is sample 4 and sample 5 were found to be the optimum amount of EPP to be improved peat soil within 30 to 40% EPP use. The use of EPP as a stabilizer may alleviate soil problem by generating stable soil with improved strength characteristic. So, as the conclusion for this research concludes that the best EPP admixture for stabilizing peat soil between 30 to 40%. It was concluded that a combination of the proper quantity of moisture, EPP, and cured peat soil helps stabilize the soil. Therefore, this research supports the hypothesis that treating peat with EPP improves the qualities of peat soil and maintains settlement over time. That's all from me. Thank you.